So to approximate the area under the graph, we have to divide the region R in n strips, where the first region has subinterval A to x1 and second region or second rectangle has subinterval from x1 to x2. And lastly, from xn minus 1 to xn. So to find the delta x or the width of the strips, we may use this formula. Delta x equal to b minus a over n, where b minus a is the width of region, b minus a is the width of our region, and n is the number of strips. Let's proceed to the definite integral about an area problem. So we have to find approximation of area under the graph of a function. So as you can see here, we consider a region R is bounded by the curve y equal to fx and the vertical line as a x equal to a, this one is the vertical line, and b equal to and x equal to b. So in order to find this region, we have to divide the region into several strips. We have to divide into several strips and we name it as R1, R2, and so on. So we can approximate the area of this region by finding the summation of area of this rectangle. Let's see how to find the area of this region. So first, we know that the area of rectangle is height multiplied by width, or f of xi multiplied by delta x. So basically, the area of rectangle I is given by this formula. Height multiplied by width equal to f of xi multiplied by delta x. So this formula is only for one rectangle. So to approximate the entire region, we have to find the summation of all area of rectangle, which is given by this formula. Or we better write it to this one. So we call this approximate of area of the rectangle as a Riemann sum. So remember that if we use only Riemann sum, which is this one, we only can find approximate area under the curve. Approximate area under the curve. If we use limit of Riemann sum, we can find the exactly area under the curve. Proceed to the definite integral. So the definition of area under the curve is also the definition of definite integral and written like this. So we have the upper limit and we have the lower limit, and this one is we call as the integrand, and we have the limit. So we will say the fx is integrable on AB if the limit is exists. So if limit is exists, so this one we will able to integrate. Fundamental theorem of calculus. So fundamental theorem of calculus, or FTC, is the connect of the integration and differentiation. So for FTC, FTC is enabling us to compute integrals using an antiderivative of the integrand rather than taking the limit of Riemann sum, because antiderivative is more simpler technique than Riemann sum. So the definition of FTC is if f is continuous on AB, so the definite integral is given by this, which is the difference of f function at B minus f function at A. So remember that capital F is antiderivative of small capital F. Thus, the derivative of f is function. The derivative of f function should be the fx, or the integral. Lastly, the equation of FTC we can written like this.
Hi, my name is Izzat. So right now I'm going to explain to you what is the application of a definite integral, which is the subtopic for the chapter 4. There's a lot of situations out there that involving the definite integral, such as to find the area under the curve and to find the area between two curves, or to find the volume of an object. But for right now, I'm going to use the definite integral just to find the arc length of a curve. How? By using this formula, which is arc length is equal to the integration of the square roots of 1 plus f of prime of x to the power 2 between a and b. How? We can use this formula to solve this question. What is this question? Izzat is trying to help his friends to find the distance between his house and the nearest multipurpose hall where his friend's wedding location will take place. So this question asks us to find the distance between two places, which is just I already marked it using that red line. So how? We're given the function which is equal to f of x actually equals to x to the power of 1 over 2. So by differentiating this function to substituting it inside the formulas, we just differentiate it, we just getting the answer and make it to the power 2. So we get it 1 over 4x. So we substitute inside the integration formula of the arc length. So we obtain the answer is equal to 12.78, which means therefore we can approximate the length of the curve of the road is actually 12.7 meter. That means that this road can be we could approximate the distance between his house and the multipurpose hall is actually equal to 12.78 meter. And that's all. Thank you.
Itulah penerangan tentang definite integral. Okey, dah tahu kan? Okey, kurang faham juga? Okey, tak apa. Saya boleh tunjukkan juga contoh soalan untuk definite integral ini supaya anda lebih faham. Okey, jom. Okey, ini adalah contoh soalan untuk definite integral. So, soalannya berbunyi, solve the definite integral below. Okay, summation from 0 to 1 for x square dx. Okay, pertama sekali kita selesaikan integral kat dalam ni, macam kita selesaikan untuk indefinite integral. So kita buat bracket in bracket from 0 to 1. Okay, dalam bracket ni kita letak for x power of 2 plus 1 per 2 plus 1. Okay, kemudian kita tambahlah power dia ni. So jadi for x power of 3 per 3 in bracket from 0 to 1. Okay, kemudian kita substitute 1 dalam x. So jadi 4 in bracket 1 power of 3 per 3 minus 4 in bracket 0 power of 3 per 3. So kita tolak, so kita dapatlah 4 over 3. Macam mana? Dah faham dah? Okey, bagus. Kalau dah faham dah, okey, boleh jawab soalan ini.
Okay, in this video, let me show you how to apply the fundamental theorem of calculus in a problem. Let's say if you want to find the integral from 1 to 3 x squared dx, so the first thing that we need to do is to find the antiderivative of x squared. To do that, add 1 to the exponents of 2 plus 1 equal to 3 and then divide it by that result 3. So this is going to be f of 3 minus f of 1. So this is the antiderivative of x squared, which is basically capital F. So let's plug in 3. 3 to the third power divided by 3 minus 1 to the third power divided by 3, and the final answer is 26 over 3. As you can see here, the outcome should be in terms of number because definite integral represent area under the curve. So the area should be in terms of number. Compare with the indefinite integral, which is without limit. It is represent the antiderivative or the family of a function. So let's try some more example. So let's try this one. What is the antiderivative of 1 to 4 square root x dx? So we just rewrite it as x1 over 2 and then we plus 1 to the exponent. So x3 over 2 divided by that result 3 over 2. Then we rearrange it to this form. So it will be easiest. So we substitute the limit and the final answer that we got is 14 over 3. So I had prepared some exercise for you guys. So hopefully you guys understand the entire of this video and all the best.